My name is Avocado and I'm presenting my capstone project called Music Accessibility. Have you ever gotten an artist recommendation from a friend? Have you ever wondered where to start when exploring an artist's extensive discography? The goal of my recommendation algorithm is to create a more targeted approach to enjoying a new artist. Instead of being introduced to an artist with random or popular songs, listeners will have the greatest chance of enjoying an artist with a data-driven recommendation algorithm to find the most accessible songs and albums. The other goal to my project was determining what exactly made a song accessible. Listeners who are unfamiliar with a song should enjoy it within their first few attempts. Accessible songs have sounds that are somewhat similar to the music a listener already enjoys. For example, if a person typically listens to mainstream pop, an accessible song for that person will sound somewhat similar to mainstream pop. However, if someone wants to become familiar with an artist's music, it is also important that the recommended songs represent the overall sound of the artist. For example, one song I feel that represents Kendrick Lamar's music very well is Sing About Me, I'm Dying of Thirst. It features expansive storytelling, a variety of voice inflections, and lush instrumentation backed by a contemporary hip-hop beat, which are all core staples of his rapping style.
Turn to settle down, my main concern. Promise that you will sing about me.
Therefore, accessible songs have a good combination of both similarity to listeners' taste and representativeness of a given artist. I decided to use Spotify audio features to calculate similarity. Spotify audio data contains variables to describe a song's sound. The variables used for this analysis include valence, danceability, energy, instrumentalness, tempo, loudness, speechiness, and acousticness. I graphed a sample of my top 50 songs' audio statistics so I could visually pick out where the center was, which is the value that describes the data best. Analyzing these graphs with Mr. Reese, we decided that the best measure of center would be to use the median for all audio features. I used the Python library Spotify, which works in conjunction with the Spotify API. I built an API in Python with the library Flask, which served as the backend of my application, basically running and calculating all the data. Here is some of the code for my API. This is hosted online currently at Python Anywhere, so anyone can call and use my API. I then built the front-end interface of my web application, which is built entirely with the JavaScript dynamic framework React. It controls all the elements on the web page and communicates with my API to pass along user info and fetch the generated data. Here is a test using the cocktail twins against my own music taste through Spotify. My algorithm sifts through the band's entire discography, finding the releases that are above a certain popularity threshold. This rules out extra material that doesn't make sense for a new listener to start with, such as live albums, demos, compilations, commentary, etc., as well as less important and non-essential albums to an artist. As displayed on the right, each audio feature was averaged out across all songs to equal one final value. For evaluating my own music tastes, the algorithm does the exact same thing except it goes through my 50 most played songs and finds the average value for each audio feature. The time span for most played song is default to last 6 months, but this can be switched in the settings menu to last 30 days or last year. The setting menu also has other customizations for the user. The final result of my algorithm is a recommendation of a total of 10 songs to the user. Both sets of data were compared to each other to generate all these recommendations. One useful feature that I added was a play button next to all of the recommended tracks. So as you could see in this example, I was originally playing a different song, and then when I played the recommended Cocktail Twins song, it started playing. As of May 2020, this app is live and is available for anyone. The URL is avocado14.github.io/musicaccessibility. For now, the bare bones of the application works perfectly for any remotely popular artist in the Spotify database. I would like to expand the features of this app, potentially doing album recommendations and using machine learning to factor ratings into recommendations. I'd like to acknowledge and give a thank you to Mr. Reese and the Capstone staff, Mr. Boyer, Mr. Harris, Mrs. Paolucci, and Miss Vella, as well as Jackie Kim, who designed my logo, all for helping me be able to complete this project.
Hi, my name is NVRHS, and this is my capstone project, Exercising in the Loop, an app that automatically mitigates low blood sugar in diabetics after exercise. So for my introduction, so basically let me start by saying type 1 diabetics use two main types of devices, insulin pumps, which allow people to have to enter insulin and bolus insulin on command, and there are continuous glucose monitors, which tell a person their blood glucose every 5 minutes often. So there's a new project, a new open source online project called Loop, which uses an algorithm to provide temporary basal insulin adjustments to a user's insulin pump by connecting these two systems. So some influences to blood glucose, including carbohydrate intake, are manually entered by the user so that the correct amount of bolus and basal insulin can be delivered. However, Loop does not take exercise into account, even though exercise has a large influence on blood sugar, often making it drop rapidly. But this is not always the case with other types of exercise, so it depends. One of the existing solutions that is used is basal overrides, but these involve manual, broad changes in basal delivery. After high-intensity interval training or HIIT workouts, there is usually a significant blood glucose drop that is affected by the level of intensity of the exercise. So my goals for this project are to create an Apple Watch app that prevents short-term low blood sugars after HIIT workouts. To do this, I would connect the app to Apple Health Kit to read and write appropriate quantities, have the app track, save, and display basic exercise quantities during workouts, have the app calculate and predict the future BG drop based on the amount of exercise performed in real time, have the app save fake insulin to help HealthKit make Loop decrease its basal, run experiments to track how HIIT workouts affect BG, and calibrate the app to run more accurate calculations. So for my main method, what I did was first research to learn how to work with HealthKit queries and reading and writing data. I created the overall app structure, which would start the workout, collect data, and send that data to HealthKit. I then built the app on the framework of Apple's Speedy Sloth example exercise app. So I first did I also, through the process, did exercise testing, where I recorded my initial BG, initial insulin on board, which is IOB, final steady BG, and calories burned after HIIT workouts, and calculated the change in BG. So here we have the user interface of the watch, which has the cancel button, the time elapsed from the beginning of the workout, the total calories burned, the current BG, predicted future BG, and heart rate. Here we have a basic hierarchy of how object types work in HealthKit, and basically just to show that what I mainly worked with were quantity types, which were sample types, which mainly involved quantitative values or metrics of health. And here we have a graph of the change in BG versus the total calories burned from my workouts, and these data points are connected by the curve of closest fit, indicating a quartic relationship between the two factors. Now we're going to go through a demonstration of the app before we continue with the poster presentation. So here we have my code that I worked on for this project. So this is mostly just stuff to get the app running, but the main function comes here. So we have our BG collection function, which uses a HK sample query in order to collect the most recent blood glucose data, and that is sent to the display to be shown and used for calculations. Next is the insulin on board collection function, which is slightly different because it's an HK statistics query with cumulative sum function, meaning that it adds up all the insulin data in Apple Health over a certain amount of time and combines it into one quantity, and it sends that to a later part also. Next we have the insulin bolus function. So here's a variable that it's basically a store for fake insulin, and what we do is if the insulin that is calculated is greater than 0.05, then it will carry through with adding that fake insulin to HealthKit, and the new bolus is calculated by subtracting the amount that it wants to do by the amount in the store to make sure it does not double count the insulin, and this insulin is saved to HealthKit. Now, when we update the interface, we do calculations and get the newest values. So here we have heart rate, active calories, which are done pretty easily, And then for the calculations here, for the insulin on board, we calculate that by using a left Riemann sum, because insulin decreases in its effect over time. So this is just a simple estimation for insulin on board. Then we calculate the total blood glucose change based on the calories and the user's exercise sensitivity factor. And lastly, we save the insulin based on this change. And here are the print messages, which will relate to a demo I will be doing now. So now I'm going to be doing a demo of the app, building it on my phone. So we're going to run it and wait for it to load. So now you can see the app is loading as it's trying to run. And any second now. So now it gives me the command to run, so I tap it. So as you can see on the user interface, we have a cancel button, the time elapsed since the beginning of the workout, the calories burned, C for current BG, F for final BG, and underneath that is the heart rate. And as you can see, I burned 1 calorie, and the predicted BG went down. So if we looked at this command prompt here, we could see on top we have total calories. We have, under that is current BG, future BG, insulin on board, and total insulin bolused. So as you can see, these values are changed and they're just meant for this demonstration, but right there it says bolus 0.08 units. So that means that based on the calculations, it felt that I needed an insulin bolus based on the amount of calories. So it saved that to HealthKit and it updated that. So here it says 0.16 units, and now the insulin store is 0.24 units. So that updates, and it keeps on getting larger as the amount of calories becomes greater. So I'm taking this video right after I did the demo. As you can see, these boluses down here and basals are from Loop, but the ones up top with the white app icon, those are from my workout app. So those are boluses that were inputted from my app into HealthKit, and basically they show that the app can bolus insulin. Now in Loop, this also has an effect. So right now my eventual blood glucose is 136, but if I close and open the app and get the effects of that, those boluses, it now goes down to 97. So that shows that when those readings are put into HealthKit, they are read by the Loop app, and the Loop app can now make adjustments to my basal insulin. In this case, it would be to decrease it in order to prevent a low blood sugar. So next, for the results, I'll walk through how the app works step by step. So first, in BG retrieval, the app executes a sample query to find the most recent BG and display it on the watch screen. After this, it calculates the insulin on board using a cumulative sum statistics query to collect insulin data from the past 3 hours and estimate insulin on board using a left Riemann sum, which is basically finding the area underneath the curve. After this is the BG prediction, where calories are collected during the workout, and the total BG change is calculated by multiplying the insulin on board effect, the calories burned, and the user's exercise sensitivity factor. This factor is kind of something I made up, where most different people have the BG drops different amounts for, let's say, the same workout. So that factor would be needed to kind of bridge the gap between people. Next, the last major step is pseudo-insulin bolusing. So the insulin equivalent to the BG drop is calculated with the user's ISF, or insulin sensitivity factor. This factor is basically a value of the amount, the total number in terms of the BG drop a person would experience if they bolused 1 unit of insulin. Now this is helpful because it can also be interpreted the other way. If a user doesn't, if a user's basal is decreased by a certain amount of insulin, they should also technically increase in their BG based on the amount of their ISF, which is basically a factor between the two. So if this insulin is greater than 0.05 units, the bolus is saved in Apple Health, and it lowers the user's BG prediction in loop and causes an appropriate basal adjustment. So here you can see we have an output window here, which shows relevant relevant variables. So it shows like the calories, current BG, future BG, insulin on board, and current total insulin bolus. And these change as more calories are accumulated. So here we see an initial view of the Loop app and a final view of the Loop app. This is before the app's effects are there, and this is after. So you can see the eventual BG is 136 on the initial, and after it's 117, which is lower, and a temporary basal decrease is enacted, which corresponds with the fact that there are samples of boluses saved in HealthKit. So basically, these are forcing the loop to decrease its basal in order to compensate for the exercise. So my conclusion is that it is possible to code for an external app to help mitigate the blood glucose drop of HIIT workouts. However, the level of effectiveness of such a method remains to be seen. There are a lot of future things I would have done, so my next steps would be mainly to expand the capabilities of the app. This would include making the app more convenient to use by fixing an issue where the user must manually close an open loop for the predicted BG and basal levels to change. I'd also create a more effective user interface to allow users to input their ISF and ESF into to be used for calculations. I would run experimental trials with more rigidly controlled variables to figure out the true mathematical relationships between IOB, calories burned, and BG drop. I'd create a step-by-step method for people to calculate their own personal ESF. I'd calculate IOB more accurately by using more complicated math and insulin absorption curves. Lastly, I would test out the app to gauge its effectiveness compared to other methods by exercising with and without the app running to compare the incidence of low blood sugars. Lastly, I would like to acknowledge Mr. Janos, Mr. Austin, Ms. Kuzmano, and David Rosenstein, all who have been very helpful in this project. Thank you for listening.
Hi, my name is Nia Watson, and I will be presenting my Honors Independent Study Capstone on race and identity and the trauma associated with experiences we have growing up. This is based on my personal experiences and is targeted to the middle school age group. Many of my first few encounters with identity issues began outside of school, where I was forced to learn about colorism, a topic that isn't taught in school. How can there still be discrimination within my own race? People make judgments and decisions based on appearance, and those with a lighter skin tone have more privilege than those with a darker skin tone. The term black is so broadly used as a general description for those with African roots that many other terms are overlooked. Not every African American has black skin. There are so many shades that a person can be, and equally as many words that can be used to describe them. Growing up, I was often told that I had bad hair. Kids around me assumed that since my hair was thick and frizzy, then it must be dirty. It's a shame to admit that I had little to no confidence in my hair until recent years. My 4AB hair differs from the common straight hair around me, but that has led me to use it to set myself apart from everyone else with the millions of hairstyles I do every day. Sometimes I'd create hairstyles which embody Afrocentricity, and other times I'd choose to straighten my hair. As I grew older, I became the target for my choice in hairstyles. I was accused of trying to be white for straightening my hair or looking too ghetto for wearing my hair naturally. Hearing these comments at such a young age really struck me and echoed in the back of my head for years. Eventually, I realized that I did my hair for me only and not to live up to their expectations. I had to learn how to deal with cultural assumptions and stereotypes around 3rd or 4th grade, which worsened by 6th or 7th grade. Unconscious bias and microaggressions are intentional or unintentional comments that are offensive to a specific group of people. Here is one common racial microaggression that I and a lot of others have had to hear. If I am correct, Africa is the second largest continent made up of 54 countries with thousands of languages. At first, I felt frustrated and questioned what basis led to their claims about the food that I ate and the music I listened to. As I grew older, though, I began to understand that the bias behind their comments was due to a lack of knowledge about cultures outside their own. Going into middle school, I was often met with questions like, "What are you?" referring to my racial background. I knew it was bound to happen sooner or later. After all, I looked nothing like the people around me. Being the only black girl made it harder to face these types of questions and comments since there was really no one I could consult or confide in. When I was much younger, the trauma controlled my life. I had social anxiety and only felt comfortable talking to people I'd known for a long time. I soon came to realize that trying to block out these things or ignore them would not make them go away. They would only go away if I did something. Sometimes the scariest thing to ask someone to do is to act, to speak up, out, or against. 10 years ago, I wouldn't have been able to give this presentation without shaking. Once I knew I had an opinion and I had something to say, I began to use my voice for what it was meant to do. My parents taught my brother and I from a very young age what it means to be black. It means you have to be 10 times more careful than the guy next to you. It means your hands have to always be visible in stores, and you pray for your life if you get pulled over by the police. Above all, it means you can never be at the wrong place at the wrong time. Having learned all this by the age of 5 is enough explanation as to why trauma can be associated with identity. I'm most certainly not the only one, and I guarantee there are many people we encounter every day who go through the same, if not worse. Just because we can't see the trauma doesn't mean it's not there. Most people don't believe me when I say hate crimes stem from the classroom. In the classroom, kids can see how the people around them act towards those who are different, and they have a choice of how to react. They make these decisions by first watching their peers and their teachers. This is most common with middle school students who are in the process of forming their own opinions about life. Many teachers aren't aware that students are watching them when they decide to ignore certain things that happen in the classroom. As a result, kids continue to grow up thinking a certain way. The kid that used a derogatory word that he saw on TV learned that he could get away with it. The kid who the word was used against learned that no one would help him, so he would have to learn how to deal with it. I gave a similar presentation to this last year at Demorest. I was later asked, if you had a chance to go back and transfer to a more diverse school, would you? I surprised myself when I answered no. I would not have learned half of what I know now if I didn't go through everything. I can confidently say it has made me a better person. Every year I have the same expectations that Black History Month will have some sort of impact on the people around me, and every year I'm disappointed. Outside of the usual 5 people, Dr. King, Rosa Parks, Harriet Tubman, Frederick Douglass, and occasionally Malcolm X, the word black is like a buzzword that everyone wants to tiptoe around, and once the month ends, the discussion ends with it. As one of the few black students within a 5-mile radius, it's often assumed that I'm related to the other few black kids in both my school and district. It doesn't make the situation any better when parents or even teachers confuse me for someone else, or ask if I'm related to the only other black person they know. With the lack of diversity in the area, the judgments that my peers made about me were mostly based on what they saw in movies or on TV. At times it felt like I was being treated like a zoo animal that everyone wanted to stop and stare at curiously. I always found myself wondering why the difference in my appearance meant so much to them when we were all just human beings.
Hello everyone, my name is Kang Hyuk, or Chris Lee, and I am currently a senior from Northern Valley Regional High School at Demorest. Today, I will be discussing my STEM Capstone exhibition poster. To start off, the topic of my research was aquatic PET plastic bioremediation through PETase bacterial recombination. This title will be explained throughout the video. In the introduction, I acknowledge the concern of plastic pollution as one of the greatest problems during our times. Especially, PET plastic, which compose our bottles and clothing, are filling up the oceans and becoming a threat to human health ecosystems, aquatic organisms, the climate, and the economy. With the discovery of a bacteria known as Ideonella sacchaensis that could consume PET plastic in Japan, a gene known as PETase that allowed PET consumption was also brought to humanity. In project goals, I discussed how I wanted to use a gene to explore bioremediation. The goal was to transform the gene into E. coli strain BL21 so that I could see if the gene could perform underwater. Therefore, the main interest of mine was to see if aquatic bioremediation would be possible since Ideonella sacchaensis was bacteria that can only survive on land, while BL21 could survive underwater. In my method/process, I mentioned that there were 4 phases to my project. In phase 1, I purchased a plasmid vector containing a mutant, which means improved PETase gene, and verified it against a reliable sequence using Sanger sequencing. The map of the plasmid vector is the first image shown. The map shows what the plasmid vector was comprised of. In phase 2, the plasmid was transformed into the target strain using a standard chemical transformation protocol, and the strain was grown on an ampicillin plate. Since the BL21 strain did not have ampicillin resistance previously, only the cells that accepted the plasmid survived. The second image of the plate shows the cells after transformation. Each white spot represents a colony of growth. In phase 3, the bacteria were placed in several conditions with plastic pellets underwater for 120 hours or approximately 5 days to test for variables such as water, IPTG, ampicillin, and albumidia. In phase 4, the pellets were measured for biodegradation through mass difference and SEM, or scanning electron microscope imaging, which was provided by Rutgers University. As for the results, there were no differences in the masses, as can be seen by the datasheet on the bottom of the process selection, but the SEM imaging, as shown in the poster, showed signs of biodegradation. All samples that had the bacteria, no matter the variable, showed those same signs, which meant that the variables did not matter as long as the bacteria was incubated with plastic. In conclusion, this experiment showed that it would be possible to use this gene to get rid of PET plastic in our bodies of water. With more efficient enzymes being produced by researchers such as the ones at MIT, this process may become faster. However, there are also dangers to this approach, such as bacterial blooms that could damage the environment. For practical implementation and safety concerns, a resourceful and responsible global organization should be in charge of this project. The acknowledgements used for this project are down below. Thank you for watching.
Hi, my name is Rita Qureshi, and my Capstone project this year is raising awareness regarding the need for improved AMR surveillance in New Jersey. My introduction is AMR refers to antimicrobial resistance, a phenomenon in which a disease-causing microbe develops the ability to survive exposure to an antimicrobial agent that was previously an effective treatment. In the U.S. alone, 2.8 million antibiotic-resistant infections occur annually, 35,000 of which result in death. These numbers are only growing as bacteria acquire resistances to multiple classes of antibiotics. Growing research in the field of AMR has shown that socioeconomic status is directly correlated to increased susceptibility to resistant infections. Now, this is a result of A, overprescription by doctors who believe that their low-income patients won't have access to healthcare in the future, B, self-medication due to lack of healthcare access as well, and C, antibiotic misuse due to a lack of education when it comes to AMR. Despite the fact that 1 out of every 9.4 New Jersey residents live in poverty, little to no data is being collected by the New Jersey government, let alone the U.S., that takes into account low-income communities. NJ hospitals are only required to report certain resistant pathogens, and the only data available to the public through systems like NVRHS and NHSN is broad and non-conducive to raising public awareness of AMR. The goals of this capstone project are to remedy the socioeconomic consequences of AMR in New Jersey through an awareness campaign. This campaign hopes to A. implement a statewide AMR surveillance system that takes income into account and makes all data collected visible to the public. B. Lobby for legislation that mandates reporting of all instances of AMR to the news system. And C. Educate the public through an easily accessible, informative website. The methodology behind this awareness campaign involved A. using graphic design platforms like Canva to create easy-to-understand infographics for mass distribution, B. using a website design platform called Wix to create an easily accessible wealth of information for both the public and health officials, and C. creating a mock surveillance system to model the ideal outcomes of this campaign. This model would emphasize transparency and ease of use. For the first graphic in this box, the caption reads, "With new legislation mandating that New Jersey hospitals report all instances of resistance to the news system, hospitals would fill out a form similar to the graphic above. The form asks for socioeconomic information like household income, size, insurance, county, sex, race, age, etc." For the next graphic, the caption reads, "An example of how data derived from the new surveillance system would be presented to the public is above." In this mock table, users have the option to sort by pathogen, county, income level, and treatment outcome. The table itself takes both income and household size into account, and trends are very easily visible. In the next box, there is a graphic that was made on Canva, an infographic, and it's informative, easily to understand, and can be distributed to healthcare facilities to raise awareness. In the next box, you can see a screen grab of the Wix website I created that will serve as a central hub for the campaign. It succinctly explains the campaign's goals and reasoning and will display the new surveillance system's data for the public to see. The data will be accompanied by graphs indicating notable trends. In order to achieve the initial goals of this awareness campaign, it is integral that it be brought to the attention of public health officials and government officials in New Jersey. These officials will be able to A. write comprehensive AMR legislation needed to ensure all instances of resistance are being accounted for, B. Update existing statewide isolate databases with the recommended changes, C. Distribute information regarding AMR to a broader range of New Jersey residents, and D. Bring county-specific trends to the attention of local officials and hospitals to then address. Some acknowledgments I would like to make are I would like to thank Mr. Austin, Mrs. Kuzmano, Mr. Janos, and Mr. Bowie for guiding me through this process, and the CDC's Disease Detective Camp for inspiring me to seek solutions for health disparities. Thank you for listening to my presentation.
The Tenneco Brook, which flows through the town of Demarest, is a tributary to the Oradell Reservoir. This reservoir is located between Haworth and Emerson and provides water to Demarest and the surrounding towns. The Tenneco Brook flows through the towns of Tenafly, Cresskill, Demarest, and Closter before depositing into the reservoir. As it flows through these towns, the brook picks up pollutants such as lead and zinc, ultimately bringing these harmful minerals into our water supply. These pollutants affect the native flora, fauna, and our drinking supply, causing harmful effects and destroying the ecosystem of our nature center. The goals of my project were to measure the LOI and the elemental makeup of the core, as well as identify and count the native flora. The first step of my project was to find a suitable site. To collect a core, a wet area near the watershed is needed. Moist, soft soil is ideal. The Demarest Nature Center is situated behind the NVD football stadium and has these conditions. Before you take the core, you must insert a slender rod into the ground to make sure the sediment is suitable. If the rod is inserted deep enough, the area is able to be cored. After inserting the rod, you can begin drilling for a core. To do this, you must use a coring device. The coring device must be inserted into the dirt and twisted, capturing the sediment. After you capture the sediment, you pull the device up and open it to reveal your core. After I retrieved the core from the site, I divided it up by depths and took samples from each section. I put these samples in crucibles to measure the elemental makeup and determine the amount of organic matter, which is the loss on ignition. To measure the LOI, loss on ignition, I first needed to remove all water from the sample. To do this, I baked the samples at a low temperature. After that, I baked the samples at 550 degrees Celsius to remove the organic content. Then I calculated the loss on ignition by dividing the initial loss by the initial weight of the sample and multiplying by 100. Next, I used all the baked samples to find the inorganic elemental makeup using an XRF test. The post-550 samples are best for the XRF test because they do not have any organic material to interfere with the results. The XRF test shoots radiation at the elements, exciting the electrons, bumping them up an energy level. As the electrons come down from that energy level, they release a specific wavelength which is measured by the XRF device. From these results, I was able to determine the elemental concentration of my samples. After conducting both the LOI and XRF tests, I decided to identify and measure the biodiversity of the ecosystem. To do this, I took samples at specific depths throughout the core, picking through clumps of organic matter for seeds. Picking the seeds was especially difficult because many of these seeds were less than a millimeter in length and covered in sedge and other organic material. My process was to first pick all the seeds from my samples and then to later identify and count them. As I picked the seeds, I placed them in vials labeled with the depth from which they were taken. At each depth, the amount of seeds varied widely. Depths with a high LOI count often had the most seeds and vice versa. I also began to pick charcoal from the samples, but I wasn't able to finish because of coronavirus. The charcoal would have given me a picture of vegetation loss from natural and anthropogenic forces. After picking the seeds and placing them in vials, I began to identify and count them. Using the drawings I made earlier, I was able to match the seeds that I found with those in scientific seed books. Eventually, I went through all the vials, counting up the seeds and identifying them. I then made a graph of the various seeds and how many of them I found. However, I noticed a significant gap in my seed graph around 50 centimeters deep. This made my job of drawing conclusions from the data difficult, so I went back to the depth and picked more seeds. Unfortunately, although I was able to pick the seeds, the lab closed before I was able to identify and count them. So, for my conclusions, although I was not able to completely finish my seed and charcoal picking, I believe that I can see several trends. The first process I observed is lake succession. I believe that the Demarest Nature Center was originally a mesotrophic lake, which over time filled in to become a eutrophic lake. The evidence for this is the disappearance of the Nias plant and its replacement with less and less typha, which are semi-aquatic, whereas the Nias plant are fully aquatic. Nias, in addition to the lake succession, I also believe there is a stress on the biodiversity because of human pollution. From my data, I can see a decline in the amount and the variety of seeds closer to the surface. In addition, the amount of large tree seeds declined significantly, and there's an increase in underbrush such as elderberries and lenticular calyxes. This indicates that the forest was distressed and there was a decline in the biodiversity. Coinciding with this decline in biodiversity is an increase in heavy metals such as lead, which I measured last year.